Let me read today's task. Fearless Frames Inc. makes metal frames for containers. So this is a metal frame all the way around that makes a container. The company has suitable metal tubing in stock to make the frame of this all the way around. Find the dimensions of the container which holds the maximum volume the company can make with 60 meters of tubing. So the question at the end is, what's the maximum volume using 60 meters of tubing? So first of all, when I look at this box or rectangular prism with a square base, what would the volume be in this case? So just how would I calculate the volume using the variables? And for a box or a rectangular prism, it's just length times width times height. So I'm going to go x times y. Now, x times x is x squared, and then times y gives me x squared times y. That will give me the volume. Now, the challenge here is that we have two variables. And for us to be able to find the maximum volume using that, we need to have a secondary equation so I can reduce this down to one variable, and then we're going to use Desmos. So where does 60 meters come in for an equation? Well, that's the tubing that makes the frame. So I need an equation that describes how much tubing I need. So if I understand the tubing right, on each side here, how many x's do I have? So I have 1, 2, 3, 4 on the one side, and then 4 more on the other side. So how many x's do I have altogether that make the tubing? And you should see that you have 8x. And then how many y's make up the tubing? So I see 1, 2, 3, 4 of those that make up the y's. And then when you add that together, that should equal to 60. That makes the frame that goes around. So don't think of it as surface area, but the edges. That makes the frame of it. So now what do I do with this equation? Well, I want to solve and do a substitution. So I'm going to solve for y to get y by itself. And whatever y equals, I'm going to take out the y and put that in so I have one variable on the right side. So a good first step to get y by itself is to subtract 8x, and then after you subtract 8x, divide everything by 4. So when I divide by 4, 60 divided by 4, 8 divided by 4, and you have 15 minus 2x. All right, now I can do a substitution. So take out the y and put in 15 minus 2x. Do I now have one equation that describes the volume with one variable only to use? So now what I'm going to do is I'm going to graph this to see what the maximum volume is going to be. So I'm going to go to Desmos. So I want to, this has to be a separate video. So I'm going to do it on a separate video. You'll see it that says Desmos video for this. So on Desmos, we're going to come back and we're going to actually figure out what that is. So press pause right now and then go to the Desmos video, and we're going to figure it out from the Desmos video. All right, here's number 2, now that we finished that with Desmos. So the client changes his mind. Now the shape is different for the tubing. What's the maximum volume here? So now I need to figure out how to find a volume, and this is called a triangular prism. Well, to find the volume of a triangular prism, it's the area of the base times the height. Now, there is a formula for an equilateral triangle. And the formula for an equilateral triangle is root 3 over 4, and then you take one of the sides and you square it. So each side is the same length. So root 3 over 4 x squared, that's the formula for an equilateral triangle. So if you didn't know it, now you know. Usually it's half the base times the height, or we use a trig formula. But if all three sides are the same length, that formula is used to find the area of an equilateral. So if you know the area of one base times the height, so it's root 3 over 4 x squared times y. So similar to what we did, we just need to have a root 3 over 4 in front. Now how much tubing do I need here? So 1, 2, 3, and then 3 on the other side. So that's 6x. How many y's make up this? 1, 2, and then 3 more down here. So 6x plus 3y equals 60. I'm going to do the same work. I'm going to get y by itself. So I'll do it over here on this side. To get y by itself, I'm going to subtract 6x and then divide everything by 3. So 60 divided by 3 and 6 divided by 3 gives me 20 minus 20x. So back here again, I have root 3 over 4 x squared, but now I have something to plug in for y, 20 minus 2x. Then I have one variable that I need to work with. Now again, I'm going to use Desmos here to find what the maximum volume is. What should x be set to give you the biggest number possible? So I want you to press pause and go back to the Desmos video that's going to help you find what that is. All right, now that you have done that, number 3 is, what advice do you think Fearless Frames should offer to this customer and show all your calculations? Well, which one of the two gave you a larger volume? And the answer is the triangular prism holds just a little bit more. So your advice I would give is triangular prism gives you a greater volume than a square prism or rectangular prism using 60 feet, 60 meters of tubing. And you did it. So you're able to do that. Anyways, Mr. G Math over now. I'm glad that you're able to do this task. Again, this video makes more sense as you go to Desmos and be able to work with Desmos to be able to figure out what those calculations are. Till next time.